welcome everyone. This is 10th week of the live tutorial session for the course Linear Algebra, NPTEL course Linear Algebra. And today we'll be discussing some problem related to matrix of a linear map. So let me start with how the matrix of a linear map is defined. Okay, so against the assumption is suppose V and W be two vector space. Suppose BW B2 vector spaces over a field F, and say T be a linear K-linear map from V to W. Also let T from V to W be a F-linear map. F-linear map. So then we actually can have a matrix we can write a matrix for this linear map, and if this is like VW or finite dimensional, then the matrix will be of finite order. If it is like whatever dimension, it depends on the order of the matrix depends on the dimension of V and W. So if Vi such that I belongs to I is a basis of V, and say W J such that J belongs to J is a basis of the vector space W, then with respect to this fixed to these two fixed bases, we have the matrix. Then the matrix of T, so we'll denote this like this as VW, say. So V by definition this like basis, and W by definition this is a basis of W. Then the matrix of T with respect to the basis VW, V and W is like denoted by M VW of T. Okay, and how is it obtained? So, and M VWT, this is belongs to the matrix of order I and J, so depending on that I J, so this of F. Okay, so then belongs to this, and if and okay, then just let me write in this form and if this MPW T equal to, if I like small ij, and I belongs to I, J belongs to J, then I need to give the how this Mij are obtained, right? So this is like T of Vi, this should be sum of So I will give me the ith column. Okay, so okay, so this is yeah, this is I missed it, so probably to take this as j and this as I, then it will be better. Yes, so this will be I, j, so this j belongs to capital J and this I belongs to capital I. Then this vi will give me ith column, vj, sorry, vj, let me write it as vj. So it will give me jth column. Okay, so jth column will be all this m ij and with wi. Okay, and here I belongs to I. So you have to calculate the linear map on the basis vector of v, and then express that as a linear combination of the basis vector of w. Then you write those like preserving the order of the basis, you write them as the column vector, like elements of the column. That's how this matrix is obtained. Okay? So this we will use throughout this session, so this notation and as well as this. So let me then first go to the first problem, which where we need to find this matrix exactly. So here the like for this ABC, these three linear maps defined for this, so we have to calculate the this matrix. And here the vector space is kt, polynomial algebra, and the basis fixed ordered basis is t power I belongs to n. So it is 1 t square, t cube, and so on. Okay, so again, just for the first one, the map is you consider a polynomial xt and map it to the derivative of that polynomial. So in general, suppose a polynomial of degree n that can have the standard form a0 plus a1 t plus a2 t square and so on up to n t power n. That is just go to, so this map, so f of xt is defined as x dot t. That means that is, if I take f of 1 plus sorry, not 1, ai t power I for I equal to 1 to n or 0 to n, then it is just sent to I ai t power I minus 1 for I equal to 0 to n, right? So I can just take because for I equal to 0 this term is already 0, so I'll start with 1 to n. Okay, so this the degree actually decreased by 1, right? So in general, but as I want the matrix, so I have to calculate this f map on the basis vector only. Here the basis vectors are t power I, so enough to just concentrate on that thing. So f of t power I, that thing is the derivative of t power I with respect to t, so that goes to just I t power I minus 1, right, for I greater equal to 1, and f of 1, which is t power 0, that goes to 0, right? So now if I write this thing in the basis vector, so basis vector, if I see, this is just the I minus 1th basis vector, like t power I minus 1, that has the coordinate coefficient I, and everything else is 0, and 1 it is everything is 0. So the matrix, if I write, it will be of the form, so the matrix n v of f, this will be, first column will be like f of 1. F of 1 is 0, and that is that means if I can write that is like 0 times t power I of I belongs to n. So the first column is 0 0 0 0 all the way up to 0. For t, that means I equal to 1, it is just 1. So 1 is the first basis vector, so that coefficient is 1, everything else is 0, right? So let me write another 0 here. For the second one, t square it is 2t, right? So again the first like constant term is 0, so that is 0. Then the coefficient of t is 2, so this is 2. Then everything else is again 0, right? And so on up to for the n, like any nth order. So this is not finite, it is keep going, because it is like n cross n, like natural number worth of elements there, right? So it is infinite order matrix. And this is like, and the nth place you will have this up at some point, it will be n t power n minus 1. So n, so this is like n minus 1th row, not nth row, this is the nth row, okay? This is nth row, you will get this. So in general, if I write just like, if I just write it in the matrix that form, then it will have mij, ij belongs to natural number n, where mij equal to like only we have just seen that for the like ith column it is t power I, so the j is exactly like I, so this is okay, ith column it is having I at the j minus 1 step, right? So it is I if j equal to, so okay, again I'm missing something. So 1 appears at the, so m 1 is 1, m 3 1 is 3 2 is 1, so exactly, so j I equal to j plus 1, right? So this is 2, so it is j if I equal to j plus 1, and 0 elsewhere. Otherwise, right? So because jth column will be the coefficient of f of t power j, so t power j has j t power j minus 1, so j minus 1th in row only consist of this j, right? So sorry, not j minus 1, jth column exactly. So jth column is this one, so I must be whenever I is j plus 1, it will be j. Fine. So that's how you get the matrix for this this derivative matrix, derivative linear map. Similarly, for the second one, if we see, it is just multiplication of two, like a fixed polynomial is fixed yt, and then you are multiplying that by like sending each polynomial and then multiplying to these. So in general, like you have whenever you have this multiplication defined in like one dimensional case, so you can send just v to some kv, where k is some like fixed constant there. So this kind of map is this. So here again, if I see just f of 1, f of 1 will be yt into 1, so that means yt, and yt is given to be just ag, so ai t power I for I equal to 0 to n. So the first column, the one, this thing is consist of all this a0 up to an and remaining thing at 0. Then again the for the like f of t, if I calculate, it will just shift the coefficient to one more, right? So this is t y t, that means it is again, so this is sum of I equal to 0 to n t ai t power I, that means it is I equal to 1 to n plus 1, and okay, no, that is it will still start with, because ai coefficient are still same, just shifting with the, like, a0 becomes now the coefficient of t, not t0. So it is I equal to 0 to n ai t power I plus 1, right? And so on. For the second thing, again you have in general t power say k, it will be sum of I equal to 0 to n ai t power k plus I, right? So the matrix here, the matrix m dv of f, this will look like a0 an, then the remaining all are 0, and it is keep going. And then next, for the next one, it will be start with a0 here, so a0 here it will be an, then again remaining all are 0, and so on, so on. It is like going like this. So so again, if I write just so mij, then mij, then mij has mij will be like for the j equal to 1, so it will be a, so just look at the pattern. So for this one is first row, this is second row, second column, third column, and so on. So for the, when it is in second column, the like a0 start from the this 2 entry, right? Otherwise it start with 1 entry. So I should write it as like for the jth column, okay, jth column it is let's say 0, so change so j equal to I, if j equal to I, then this is a0, it is a1 when j is I minus 1. So for the a1, it will for a1 here the I is 2, so 2 minus 1, that is 1, so this is 1, sorry, 2 entry, so 2 is like yes, 2 is a1, so all the way up to an. This will start when jh I minus n, right, and remaining else are 0 otherwise. Clear? So we'll get the mij as this, because the first non-zero entry first always appears at the this diagonal thing. So whenever I and j are same, the entry is a0 always, and for the next, just below the diagonal, you have a1, so there j is I minus 1, and so on up to I minus n, right? So fine. And now the next map is given by xt goes to x of t plus 1. So again, ch here f of 1 is the constant polynomial, right? So f of 1 x of t equal to 1 here, so x of t plus 1 will be again 1, so f of 1 equal to 1, and then f of t equal to this is t plus 1, right? Because f of t plus, this is t plus 1, t square if I take, it is just t plus 1 square, that means it is t square plus 2t plus 1. If I just do for t power n t power n, then it is t plus 1 whole power n. So this you know by binomial expansion that this is n choose I t power I or I equal to 0 to n, right? So this you can this you always have. So the matrix you now get as then MPV of f, this is for the first one, this is just 1, everything else is 0. For second one, it is t plus 1, so first this one is 1, second one is 1, remaining else are 0. For the third one, this is again 1, 2, 1, right? Remaining else are again 0, 0. And at the nth step in this thing, you get this first is n choose 0, second one is n choose 1, and so on up to n choose n, right? The nth row. So in this way you will get the remaining else is 0, so you will get the matrix. So here if I write if I just say this is mij, then what is mij? Mij will be for the ith thing you have j component, so this is okay, so this is 1. So this is basically nth, n, when I'm considering this is n0 n1, this is actually n plus 1th column, right? So for the jth column you will have j minus 1 choose I minus 1, right? Because this is the first row. For example, this is 1 1, this is 0 choose 0, so that is 1, not defined although, but this is for the this entry you just take it to be that 0 choose 0 is not defined, but this is I write that j greater than 1, j greater than 1, and I is also less equal to j, I less equal to j, because otherwise it does not make sense this j minus 1 choose I minus 1. right? And for this one, when j greater than 1, I is this, and m11 is 1, and mij equal to 0 otherwise. So in this way, actually, you have to whenever you have you have to find the matrix of a linear map. You just write it in this form, because in this case you have infinite order of the matrix as infinite order, so you can't write in this form clearly. So you just write it as like some entries are defined as mij. Then you specify where in which place you have the which entry. Here you see that this matrix actually is a upper triangular matrix, and all the diagonal entries are just 1, right? So this is also a invertible matrix. In the previous case, if we see, so there the diagonal, it was a lower triangular matrix, right? Because the diagonal entry always are a0. If a0 was 0, then this is not an invertible matrix. And for the first one, you again have one at the, so this is again a non-invertible matrix, because one row the first column, not row, first column is completely 0, so this is again not invertible. Okay, so you may use these things to find also to find the inverse of a matrix. Okay, so this you have seen in class, that if a map is invertible, then the matrix of that inverse map is the matrix inverse of the original map, right? So so similar question will have one. So let me just take that. Bisal, okay. Oh, previous, can you just explain what you mean? Like previous paper of linear algebra format means? Bisal? Hello? So can you say what you mean this format of previous paper of linear algebra means? Okay. Okay, fine. Fine. But I don't get actually what you mean, so maybe if you can type it clearly, I will. Okay, so next question is this one, that for any matrix A, m cross n matrix with entries in K, some field K say, and then if you we need to find the product of Eij times A and A times ERS, where Eij are the basis element, standard basis element of m cross m matrices, and ERS are of n cross n matrices. Okay, so standard basis elements, so these standard basis element are So just when we mean this Eij or Rs, so this matrix has like all the entries 0 except at the ijth position. Ijth position it is 1. So Aij equal to just let me write it as small Eij matrix. So it is suppose m cross m matrix. So Ij equal to 1 to n, both n. Okay, so this Eij equal to delta ij. Like delta ij means that is 0 only if I equal okay, not this is ij, sorry, this is not. I should consider something else notation, because this is also Eij, so let me write it Mn. Okay, Mn is also say PQ. Okay, so PQ both are from 1 to n, because this Eij is an m cross n matrix. So this is PQ, and EPQ equal to 1 if PQ equal to I comma j and 0 otherwise. Similarly for like ERS, only the RS in RS position is 1, everything else entry at 0. Okay, then that is that is standard basis of an any m cross n matrix in K. Now if I have to I need to calculate this product. So by product rule, suppose A was some let's say A QR, or not QR, some EF. Okay, AEF. So again E runs from, it is m cross n, so number of rows 1 less equal to E less equal to m, and 1 less equal to F less equal to n. Okay, then let us calculate this Eij A. Suppose the entries of this thing is some CST. So this is Eij is an n cross n matrix, m cross m matrix. Sorry, this should be m, right? Yeah, m cross m matrix, and A is an again m cross n matrix. So still it is an m cross n matrix. So 1 less equal to S less equal to m, 1 less equal to T less equal to n, and CST by matrix product rule, it will be Eij is this EPQ. So E S K and AK T KT for K equal to 1 to m, right? Yeah, so this is I know only this is if S equal to I and K equal to J, then only this is 1, everything otherwise it is 0, right? So the only surviving term is here when this is 0 if S not equal to I. Obviously whenever S is not equal to I, it is clearly 0, because that's the only possible entry. If S equal to I, then for the K equal to J, I will have 1, so that will give me a J T, right? fine. So this k is running over all the 1 through m, and this so for the k equal to j, I'll get that this is eij. For eij I know this is 1, so for that entry I'll only get ajt, right? So this matrix actually you get that only at the ith row you will get the all the entries like jt, j1, j2, aj1, aj2, aj3, right? So if I write it in this thing, so eija equal to the ith thing, suppose this is the ith row, then t equal to 1 say, so if t equal to 1, that means first column it is j1, aj2 all the way aj m, right? So it has n column, sorry, so this is jn, everything else is 0, and this is the ith column, ith row. So when you multiply in this called all elementary matrices, so by elementary matrix on the left you get actually the jth row in the jth row, originally jth row of the A matrix at the ith row as a ith row, right? So that's what you are getting. Similarly, for the, just check that for the second one, if you multiply again elementary matrix on the right side, then you will get the column, eighth column on the rth column of the A matrix. Okay, so that is just simple this calculation, not doing that one. So let me go to the next problem. So here you are given a map F from V to W, and V is n-dimensional vector space, W is m-dimensional vector space. Then we need to show that there exists basis V, which is consists of the vectors V1, V2, Vn, and a basis W consists of W1, W2, Wm, such that the matrix, if I write the matrix of F with respect to this ordered basis V and W, then I'll have this form, where this first some k cross k box will be just identity matrix, and everything else will be the zero matrix. So this k is exactly the rank of F, and it is uniquely determined. Hence, so the thing is, I want this, so from this representation I can see clearly that, so that we want this V1, V2, Vn basis and W1, W2, Wm basis such that Vw such that F of this Vi, that will be clearly some Wi for 1 less equal to I less equal to rank of F, and 0 otherwise. Then we are done, right? But this means we have to f of Vi equal to 0 for, so we have to somehow start with the kernel of F, right? so that I will get some like basis of kernel of f, where and then I will extend that basis to a basis of v, and on the remaining the extended basis the f cannot be 0, so that will exactly generate the image of f. So and from there, if I just take f of vi to be wi and extend that to be again a basis, we'll get the required this v and w. So let me just write it. So from this thing I can clearly see that, so kernel of f is a like subspace of v, and v is finite dimensional. V is like n dimensional, or is n dimensional. And so consider, suppose this and let's say v k2, also let's say the image rank of f equal to k. Okay, let k equal to rank of f. Again, as w is finite dimensional, so rank f also must be finite, so I will just take that k as the rank. And now you can consider the basis, consider a basis like by the rank nullity theorem, I know the kernel must be of like dimension n minus k, right? Because it has the dimension of v is n and rank of f equal to k, so the kernel, the like nullity of f or dimension of the kernel f must be n minus k, right? So I'll just consider a basis v of n minus or just this is k plus 1 through vn of kernel f. Okay, so consider this basis of kernel f and extend it to basis, and extend it to a basis v1 to vk, vk plus 1 vn of v. Okay, now as this is kernel of, so clearly I have f of v I equal to 0 for k plus 1 less equal to I less equal to n, and for the other thing f I and f of v1 just f of vk, this will be because this is a basis of v, so the image of f is generated by this fv1 fv2 fvk up to fvn, but vk plus 1 to vn, all those are 0, so the only remaining term are f of v1 f of v2 up to f of vk, and so as the rank of image this rank of f equal to k, and these are the generating set, so this actually this is a basis of image f. So then it's a basis of image of f or f of v if you want, that means f of whole space, image space. So now so is a basis of this, and this is a subspace of w, so I can again extend this to a basis of w. So define wi equal to f of vi for 1 less equal to I less equal to k, and extend this w uh, w1 through wk to a basis w1 to wm of w, because w has the dimension m. So now we are done. So that's what we wanted clearly. Then we have f of vi equal to wi for 1 less equal to I less equal to k and 0 otherwise, right? 0 for k plus 1 less equal to I less equal to. So then the matrix is clearly the, if I write m of mv w of a, this is exactly like 1 1 1 up to kth order. So else is this is 0 matrix, this is 0 matrix, this is 0 matrix. So that's the required thing. So you have to first start with the basis of the kernel f, then extend it to a basis of v, and then consider the like w such that image of f is generated by that extended extra basis of the v. So in this way you will get this thing. And for the last question, let me consider another one. So this is basically interesting one. Just so as I mentioned earlier, that you can actually use this like linear map to calculate inverse of a matrix. Like sometimes it is easier than the like normal matrix inverse, using this minor thing, adjoint matrix and those things. So instead of going to that calculation, you can actually use linear maps for some cases to calculate the inverse of a matrix, because it is like inverse of a. So here actually we use that, we will use if f from v to w is an invertible linear map, and vw be fixed vw at fixed basis of vw respectively. Then if you calculate the matrix of f and then take the inverse, so that will give me the inverse like matrix of the inverse map, because this is invertible, so if inverse exists, and that will be again a linear map. So that is a map from w to v. So if you calculate that matrix of that linear f inverse with respect to the reverse order wv basis, then you will have this one. So we'll actually compute this. One can compute the matrix inverse of this matrix by this adjoint, calculating the adjoint matrix, but that will be little bit tedious, because it is a like n cross n matrix, and you have to anyway calculate the determinant somewhere. So that's why we can use this one and can calculate the inverse of this. So first, uh, so the main thing is we need to define a linear map that associate this matrix, and then we will just calculate the inverse of that linear map um, to get the inverse of this map, right? So just fix a let's say v1 v2 vn be any basis. So let v equal to v1 v2. So this is an n plus 2 matrix, so I should the dimension of v whatever I consider, it should be n plus 2, right? So let that to be a basis of v, and then consider another basis of v, and as I want the matrix of that thing is of this form, so I should consider another w equal to w1 w2 wn plus 2, such that this wi, this is okay, not wi, let's say w1 is v1, because I will define f of v1 equal to w1, then this column will clearly be only consist of only 1. Then if I take v2, it should be something a1 times w1 plus a2 w2, right? So sorry, v2. So this thing is okay, w2 is, I will define it to be v2 plus a1 v1. Okay, so right, so this thing, and similarly up to w n minus 1, or let's say in general I, this is vi plus ai minus 1 v1 for I equal to 2 to n, 2 less equal to I less equal to n plus 1. And for the n plus 2, again you define that to be this c1 vn plus 2 plus vn minus 1, and all the way up to c v1. Now if you define a linear map, and okay, just let me write it as wn plus 2 as vn plus 2 plus bi v n minus I equal to 1 to n, right? So I'm missing something, so this is bn, okay, this is not n minus I, this is just I plus 1, sorry, because b1 is v2, b1 is the coefficient for v2, so this thing plus c of v1. So then you just define f from v to w by, so one thing to note, that this w is again a basis of v. By this definition of w, whenever v is a basis for any choice of let's say this a1 and ai and bi, ai, bi and c, this is always a basis. This one can check directly. And then once you have basis, you can define a linear map that takes this basis to this basis, right? So it is just a so not v w, but in this case I am considering both as v. Okay, So define f v to v by, so invariably we also using that the dimension of v is n plus 2. Okay, so define by f of vi equal to wi. Now if I write the matrix of this f with respect to both as the basis of this v and v itself, so that will give me this matrix. Let me write it as say A. Okay, so then exactly the matrix will get is A. So the A inverse, then A inverse will be the matrix of F inverse, but in this case the basis should be with respect to this W, right, which is F of V. So this is actually I'm not using this one, but this thing, that VV both as V this is also true, but we are not using this one, but like a different version of that one, that type of geometric linear map and VJ basis. So this is also true that whenever you have an invertible linear map, then it takes a basis of that vector space to a basis of the to the other. Okay, so in this case actually the basis choice of the basis for the inverse matrix, it should be just f of v. So f of v, and by my choice this is this w is the f of v. Okay, f of v basis of v, then this one. Okay, so in this case this A inverse then will be m w of f inverse, but f inverse is easy to again calculate because I need to like express my this wi as in terms of wi, right? Then I can clearly get this f inverse. So because f inverse of w 1, so this is v1, which is just again w1, and f inverse of say w2 okay, again I'm missing something probably. So w2 equal to v2, so v2 equal to, okay, so v like wi equal to vi plus a minus 1, so wi, so f of vi equal to wi equal to vi plus ai minus 1 into v1. That means f inverse of wi equal to vi, but vi again is wi minus ai minus 1 of v1, but v1 is w1. So similarly I just write I equal to wi minus ai minus 1 of w1. So this is true for 2 less equal to I less equal to n plus 1, and for the f inverse of w n plus 2, n plus 2 is clearly vn plus 2. So vn plus 2 again I will write that is wn plus 2 minus like vi plus 1, but vi plus 1 again uh, is, so this is I equal to 1 to n vi plus 1. I just calculated, this is wi plus 1 plus not plus minus wi plus 1 minus ai v1, right? And next this cv1 is cw1. So just arrange everything in order to get that this is wn plus 2. Then you have from this is diw I plus 1 from I equal to 1 to n, and then everything is this v1 is again w1, so this is plus ai bi I equal to 1 to n, this plus c whole into w1. Okay, so you get that's how then this simply a inverse will be this is 1 0 0 0 all the way up to 0, also 1 in this thing, because always f inverse of wi is always there 1, so this is again the diagonal, this thing is 1, and everything else this is I'm getting for 2 this is minus a1, right? So this is minus a1, this will bring in minus a2 all the way up to minus an, and okay, so this is 1, and then again you have 1 here, you also have 1, this is just okay. For the last entry it will be minus for the 2 it will be minus b1, right? So this will be minus b1, so this is something c minus this thing c plus, so c plus summation ai bi, this is minus b1 minus b2 all the way to minus bn, and this is 1. Okay, so this is 1 1 all the way up to 1, and then remaining this is 0, this is 0. Okay, so this will be the a inverse. So you can calculate this, but directly, but this is like more more use of the using the linear map and inverse to get the direct inverse map. Okay, so it's already time, so let me stop here, and is there any other question related to this one, or okay? And Bisal, so okay, so you mean July October, just a minute. So you were saying July October 2021, but was that different from this one? I don't know, I don't have that. I only have like this year question paper and the in the 17 one probably. I didn't have this July October thing, so probably if you have, you can you can send so that we can discuss next time. Any session, okay, but these questions are anyway from the assignment only, right? So these are like the question you don't have to submit. Those question I'm only some of the question I'm only considering here. and the question are almost the same as I have seen that for the 17 one also, the like 2017 17, the question are almost the same, only sir changed some like parts, um, like which was there you need to submit, sir gave it here, that for practice. So the question you check that, the question are I'm discussing only from the assignment only. I was not like I'm not able to discuss all the question due to the time, but I'm considering the question from the assignment only. But I can't solve the question which are you like you need to submit. So anyway, okay. So if is there any other question like related to today's thing or previous, Vishal? Okay, then we'll stop here, and again like we'll meet next week. Like another, like the 2 more week is there for this thing. So probably again we'll discuss some question related to the next assignment, week 11 and 12, and that will end the thing. Okay, so by then,
Thank you, sir.
thank you.